section we discuss the vector nature of angular variables. Consider the angular velocity vector of an object rotating about an axis. The direction of the angular velocity vector is defined by the right-hand rule, which is applied as follows. Grasp the axis of rotation with your right hand so that your fingers circle the axis in the same sense as the rotation. Your extended thumb then points in the direction of the angular velocity vector. Consider a rotating disk. First, wrap the fingers of your right hand as shown. Your extended thumb then points in the direction of the angular velocity vector. If the disk were rotating in the opposite direction, you would have to flip your hand over so that your fingers wrap in the same direction as the rotation. Your thumb now points in the opposite direction as it had in the previous case. Now consider the following case, which is a device used to calculate the speeds of bullets. The right-hand rule indicates that the angular velocity vector points along the rotary shaft toward the motor. In this spinning miniature golf windmill, if you wrap the fingers of your right hand in the same sense as the rotating blades, your thumb points directly into and perpendicular to the screen. If it were instead rotating in the opposite direction, your thumb would point directly out of and perpendicular to the screen. Applying the right-hand rule requires the ability to visualize a physical problem in 3 dimensions. And sometimes you'll have to visualize a 3-dimensional object rotating about an axis. In the case of the Earth rotating about its axis, in applying the right-hand rule, you wrap your fingers around the axis of rotation. Your extended thumb again points in the direction of the angular velocity vector. Other angular variables also have directions associated with them and are therefore vectors. Recall that the angular velocity is equal to the angular displacement divided by the elapsed time. Therefore, the angular displacement is also a vector that points along the axis of rotation in the same direction as the angular velocity vector. Finally, an angular acceleration arises when the angular velocity changes, and the angular acceleration also points along the axis of rotation. The angular acceleration vector has the same direction as the change in the angular velocity vector.